Welcome to subtopic 2.3 position time graph. Today we're gonna solve the free response. Question number 1. Refer to the diagram below to answer questions A to F below. What is the position of the object at 6 seconds? So, the position is actually on the y-axis. At time equals to 6, I will try to find the position, yet it is here. So the position is at 9 meters. Don't forget to put the unit. Question B. How much time has passed when the object is at 6 meters? How much time when it is at 6? So at the time, when he was at 6, he eventually went from 0 to 4, which is 4 seconds. Later, question C. How far does the object travel for every second it is in motion? So, actually I can see that he is covering every 2 seconds, he is covering 3 meters. Every 2 seconds he's covering 3 meters. So every 1 second he's doing only half of the 3, which is only 1.5. So basically he's doing 1.5 meters every 1 second. If the object continues at this speed, question D. When will the object reach 18 meters? So the same speed means he's having a speed equals to 1.5. When will the object reach 18? So actually on the graph, the maximum is 12. So the graph will not help me much. So let's return to our equation that says that the velocity average equals to the displacement divided by the time. And the time is actually here what is in question. Given that the average velocity is 1.5, when he will be at 18, what is the time interval? After computing, delta t equals to 18 over 1.5, which is 12. Don't forget to put the unit. Part E, where will the object be after 3 seconds? So here, given the time, where, this means delta x, also applying the same equation, V average equals to the displacement over time. Now I have the velocity, I have the time, not the displacement. Delta x is, after cross multiplication, equals to 1.5 by 300, which is 450 meters. And that's it for question number 1. Question number 2. Actually, here we have the position time graph below representing the motion of 2 joggers. Let's say here we have the red jogger and the blue jogger. Which jogger has a higher speed? having a higher speed, basically we can simply say the speed is actually the steepness or the slope. For that, I can see that the red jogger has a steeper line. For that, the red jogger has a higher speed as its line is steeper. So I can say that the red, in red I'm writing it, the red jogger has a higher speed as its line is steeper. Or also in other terms, we can say that as they started from the same position, after the same amount of time, which is, let's fix it to 2 seconds, the blue jogger only went 2 meters while the red jogger during the same 2 seconds was able to go from 0 to 4 here. So the displacement of the red jogger is bigger than the displacement of the blue jogger during the same amount of time. Part B. Will the blue jogger catch up to the red jogger during the motion shown in the graph? How can you tell? Are they ever gonna meet? I can see that the further we go, the further the time passes, the lines are getting only further apart. So we can simply say that no, because the lines representing the red and blue jogger, they only get further as time passes, further apart as time increases. Finally, how far apart means I need to find the distance between them, where the two runners at the time equals to 2 seconds. At the time equals to 2 seconds here, all right, what is the distance between my two joggers? So at 2 seconds, the blue jogger was at 2. The blue jogger was here. And also at 2 seconds, the red jogger was at 4. So what is the distance between them at 2 seconds? The blue jogger was at 2, the red jogger was at 4. So simply, the distance between them, let's say delta x, is the position of the red minus the position of the blue, which is 4 minus 2. They were 2 meters apart. Thank you.